Hello, ladies and gentlemen, boys and girls. Welcome to VUX World. I am thrilled to welcome our guest today, Nikolai Rozanov, who is the CTO and co-founder of Wluper. I'm pronouncing that right, aren't I? Wluper?
Yeah. Very good
Perfect.
pronunciation.
Perfect. Nikolai, welcome. Welcome to VUX World.
Hi, everyone. And hi, Kane. Thanks for having me.
No worries, no worries. It's a pleasure. It's a pleasure. Excited to get into the conversation today. Excited to hear a little bit more about Wluper and the work you've been doing. I think you're finding from our conversations, you're finding a very sweet spot in the marketplace that few others really have I think some have been searching for, and we'll probably get into other examples of where there's been activity in this space in providing voice and conversational solutions for field workers and people out in the field doing work, trying to be more productive. But there isn't a terrible amount of examples out there of solutions and providers doing really good work. So I'm excited to get into that technology, into the use cases, and all that kind of stuff. So I appreciate you spending some time with us. Before we do that, though, it'd be nice to learn a little bit about yourself, Nikolai, a bit about your background and what led you to co-founding Wluper.
Yeah, definitely. I'm very happy to be in the show. So thanks again, and very excited to share more about our story. But let me get more into myself first. So I guess just to start with a brief history about me. So academically, I started with mathematics actually in London, machine learning, a couple of research placements here and there. Then went a little bit into the startup industry, so it got a little bit of experience. But then I was quite lucky to meet my two co-founders, Hami and Maurice, and then we basically started our conversational AI startup. And maybe to speak a little bit of where that came from, the inspiration for it is, I guess the inspiration came from all those big and awesome tech companies and role models, the people that founded them, that worked on very cool technology that had high impact on the world. And so that was kind of the shared vision and dream that all the three co-founders basically had, and that's how we started Wluper all that while ago. Yeah.
Interesting. What examples are you talking about? Kind of like the big examples, like Bezos and etc. Or are you talking about sort of like the industry specific examples? Like Adam Chaya and those kind of guys. Who was your kind of inspiration when you were
Yeah,
getting started?
so a little bit a mix of everything, right? So obviously the big ones were probably Apple, and these days more maybe Tesla and so on is quite inspiring. But then also the founders of Stripe, so something also like Patrick, met him once, not personally, but I saw a talk like a couple of years ago, and so these are definitely role models that you can see that it's high impact, but also always technology driven, and so it's a mix of these two things that really the mix of them which excites me personally. Yeah, to pursue that.
Interesting. So why conversational AI then? What was it specifically? Was it voice predominantly or conversational AI, kind of NLP in general? Like what drew you to it and why did you focus on conversational AI to start?
Yeah, no, very good question. So I think conversation is one of these things that definitely got oversold a little bit when we first heard of Siri. But then we know about it for much longer from all the movies, starting even with 2001 Space Odyssey, right? So we know about these machines that can talk, and then from Star Wars. So it is definitely a very cool and very permeating topic. But then when we first saw it in the real world, we got quite disappointed, I would say, because obviously there is a big expectation gap. And so actually, it was in 2016, I think, where Hami, a co-founder, he was looking at the map of London to go to the London Film Festival, and he was saying he didn't. It was the first time in London, and he was saying like, how does it work? Like, what are those zones? What's the price? How do I calculate it? So it's just very simple questions. And he was wondering like, why isn't there a Siri that works perfectly, but just for one domain at a time? So that was kind of the idea. Those two things together, basically like practical problems, that why isn't there something working for a specific domain, together with the general attraction to this topic, which led us to conversational AI.
Interesting. And had any of you had any prior experience with conversational AI systems, or was it at the time you'd obviously used Siri, you'd used maybe, I don't know, 2016, perhaps you'd got your hands on an Alexa device or something like that. Had any of you, you mentioned your education was mathematics, had any of you had any experience with building any of these kind of systems, or was it just purely because you'd used them and you thought that they would be a nice fit for that kind of use case?
Yes, very good question. I guess we've had definitely experience using them and testing them out, and also the less famous ones as well. So I remember back then there was still a company called Snips that we've been testing out as well, I guess. But basically, all three co-founders are technical, and so Hami, Maurice, and myself, we all did computer science academically as well, apart from other things, and we've been working independently on various systems that had to do with machine learning, going closer into NLP as well. So that was kind of, I think, the extent of our understanding of the field, is that we've worked with similar technology. I guess one thing that we did not have is actually a full experience in delivering it to the real world. So we had more of a theoretical knowledge of it when we started.
Interesting. I suppose we should ask what Wluper is and what it does, but I'm interested to carry on this thread of the journey to it, basically. So you kind of have this idea, you've noticed that there's potentially something to do with domain specific voice assistants in some way, shape, or form. You've all got a technical background as such, and so you can probably, I imagine, get familiar with these kind of machine learning principles and all that kind of stuff. So I'm keen to get into some of the things that you learned straight away when you first started trying to build something. But before we get to that, maybe we should just, for those that are tuning in who've never really come across Wluper before, in a nutshell, what is it that Wluper actually does today?
Yeah, no, very good. So what is Wluper? Wluper is still actually, in philosophy and principle, it's the same goal that we have as when we set out, which was led by the question, why isn't there a perfect Siri or perfect conversational AI really for specific domains? Why is it that they're failing? And what we want to do is to, and we actually are successful to some extent already, is to bring conversational AI for one domain at a time that is working really well. And so when you think of our tagline that some people always ask us about, like, what does it really mean? What does our tagline mean? Our tagline is building real conversational AI. And what we mean by that is precisely that. It's giving to people, to users, to everyone, a voice experience, a conversational voice experience that's actually real and working, right? So something where you don't get frustrated after you ask the first question or the second question, where you can actually carry on, have a back and forth, a real conversation. So that is why we created this tagline, real conversational AI. And that is still our plan from the beginning until today.
Interesting. So let's continue that thread then, because I've got a few questions around this domain specific NLU stuff as well, because we've referenced it a few times on the podcast. Like, where will NLU systems go? Will they become this domain specific kind of NLUs that we see? I know Kai from Casisto is very much focused on banking NLU, and maybe we'll chat about that. But I'm keen just to step back a sec to get into this journey then, when you're first starting to look at Wluper, the concept, you're kind of starting that journey. What were some of the things that you learned early on when it comes to building either NLU models or building conversational AI? What were some of those kind of early lessons that you learned that you think would be relevant for anyone else considering either developing their understanding of these systems or building something themselves?
It's a very, very good question. It's definitely a throwback a little bit. So we really kicked it off 2017. So in 2017, we kind of we founded a company already, and we started building stuff. And so the very early experience that we got is we tried to first use existing a lot of the existing technologies back then. So the Alexa's SDK and a couple of other SDKs were available, and we tried to use them. And what we really found out quite quickly is that being a developer in these SDKs is first of all, it's not the best experience, but also you don't get very far. Like, you can replicate functionality of the big players, but you cannot really push it much further than that, or it's really, really difficult. And so that led us to actually understanding that we need to specialize in the technology itself as well, right? And by having built using existing frameworks, we understood where the bottlenecks actually were. And then the other thing that was very, very instrumental, and we were very lucky on that front, is to, of course, get very, very experienced people to advise us and actually help us build. So we actually hired 2 super talented engineers that have been both working on machine learning and NLP and had published papers. And they're still with us today. So that is, I guess, a great story. And we got a great advisor, a professor, from quite a renowned professor in the NLP and dialogue space. And this combination led us to actually understanding the technical problem much, much better, and leading to us developing our own technology, which wasn't possible with the SDKs that were available.
Interesting. What kind of things weren't possible? Like, what limits were you hitting when you were trying to use Alexa's SDK and some of the other tool sets out there? Like, what did you have to do? What did you have to make possible?
Yeah. So the list is actually quite big, but I will try to focus on the main
the big ones.
Yeah, it's I think we can spend the next day speaking about these things, but I guess the main things, and those are also the technologies that we have since developed because to address these issues. So one is the NLU itself wasn't very good in the sense of you give it training data and you want it to understand specific things, and it doesn't, right? So and of course you don't want to write rules that if you see this then do that. You rather wanted to learn these things. So that was one. Then the other was that the classical structure of intents and slots, which is what I guess the technical people are more familiar with, it really doesn't scale that well. And just to give you an example, imagine you want to build something for basically a navigation system, but also something that can find locations for you. So maybe you would like to have a use case like find me a nice restaurant around King's Cross. And then another use case or another intent would be, please get me to King's Cross. But what if the user now says, could you get me to the nice restaurant in King's Cross? Which of these two intents is it? How do you combine them? And so conventional systems break down. And the interesting thing is that this compositionality is actually very, very common in human language. Almost everything we say is compositional. We communicate in units of meaning. And so this was another big bottleneck that we found, is that this, by imposing a strict intent structure and slot structure onto your problem, you are limited to this definition. But human nature is, when you speak about even a very narrow topic, you use compositionality, and your intent structure breaks down very quickly. So that was a big bottleneck that we found. And then the third bottleneck was more on the memory side of things. So like keeping track of memory was it's I would say impossible, except for rule-based memory tracking. It was impossible to actually track memory in a good way, right? And therefore any follow-up question, so you could say, oh, when does the restaurant close? Or hey, if we stick to the same domain, it wouldn't be very easily possible. Like, you would always have to hack the system. So memory as a third one. And the fourth one was actually the dialogue management itself. So knowing what to respond, how to deal with what if the user didn't say something, or what if something was misunderstood, or ambiguity and disambiguating. So all of these features that you would want from this system all of that was basically on the dialogue side was not possible. So just to summarize, on the NLU side, it was the actual performance of the NLU and this limiting feature of intent and slot structures. And then on the dialogue side, it's the memory and the actual dialogue management in terms of policy and responses. So how to actually respond to the user, how to manage the conversation. These things were very, very challenging and still are, given those generic frameworks. And so that is what we've been focusing on when building our own technology.
Interesting. That's really interesting. That I'm curious then to know how do you break out of that intent and slot filling mentality? Because I know there's a couple of other companies that are not necessarily basing their models on intents and slots, but the vast majority still do. And I don't know whether that's a hangover from kind of like predominantly chat inputs into most of these systems. A lot of the platforms out there originated as chatbot platforms initially, and then you put a speech recognition system in front of it, and all of a sudden you've got a voice platform. But it's built on those foundations. So I'm curious to your thoughts and how you managed to kind of get around that, like obviously without giving away the secret sauce, but what's the general kind of what's an alternative to slots and intents and slots?
It definitely is part of our secret sauce, right? So, but I
thought you'd say that.
I can maybe give you an intuition behind one approach of thinking of an alternative, right? I'm sure there are actually many ways of overcoming it, and some will be better than others, and in some cases, as you say correctly, maybe you don't need to overcome it. If you think of those classical chatbots where you're given options of clicking buttons, well, that's not real conversational AI in our opinion. This is more of, it's just a very good user interface that it's like you can choose buttons and go through a checklist very quickly. But if you're thinking of actually being able to talk or to even write to something, but that can actually respond back and forth without giving you predefined options, this is where the intent structure breaks down. And one way to maybe go beyond it is, instead of thinking about how can the user say something, and then giving many examples of that, it's to really focus on what can the user speak about. And people would say, oh, but this is what intents are about. But that's not true. The intents is more, you are not actually defining what the user can speak about, is you're imposing specific things, how the user should interact with your system. But when we speak about the what, it's really about what is it that if there was a human on the other, so if you were to call this company that you want to interact with, or the service, what would the human be able to do on the website instead of you, right? So you speak to this human and the human does it for you. So you could click on maybe this part of the website, you could maybe do this part of the website, or you could report an issue, or you could, book something, etc., etc. So it's actually the functionality that is available on whatever service or website or company that you're accessing. That is the what. It's the actual thing that exists already. And it's more about defining and thinking about that, as opposed to how can then the user interact with that. And this is kind of the stage that we are abstracting. We are making it much simpler to just define the what, which most companies know anyway, because they provide the service without any conversational AI, and we take care of the how, and our technology takes care of the how, without needing to go via intents in the classical sense. Yeah.
Interesting. The way you kind of had me thinking there in terms of relaying that conversation between a, let's say, a customer and a call handler, is that the call handler has lots of options to them, which makes me think that perhaps in the outset you might not be trying to find something specific. You might just be trying to understand a ballpark range of stuff that the user might be interested in, and then presenting that and letting them determine what it is that they might want off the back of it. Is that kind of describing it right? Are you not looking for like huge accuracy at the start, or is it still that? Is it still like accurate from the beginning?
No. It is actually accurate from the very beginning. So rather, maybe to just give an example of a customer service with where you can book something. Yeah, maybe you can book appointments at your local hairdresser, let's say, and you could book them, you could maybe cancel them, you could maybe postpone them. So these would be like classical, maybe intents. But then the functionality of the website is already given, right? Or the functionality of what the hairdresser maybe does without a website. If they don't have a website that allows all of that, they would do it manually, but they would do something somewhere, right? And it is more about describing what is it that is available as a service to the user, and our NLU just maps against it without having to figure, without predefining, oh, when the user says this, this is this intent, and this intent should trigger this function. It's rather, no, let's skip this part. Let's just focus, what are the functions, right? What are the functions that are available? And we map what the user says against those functions. It doesn't matter if it was this intent or that intent. The user wanted this function to be triggered, then this function to be triggered. So it's more about describing the functions. And then high precision, high accuracy is super important. Yeah.
Right. Interesting. Yeah. So you're doing away with the middle bit, basically, which is the pipeline of getting the intent, extracting the slots, and then reaching back out into whatever it is that you're trying to do. You're trying to just get rid of the middle. Sounds strange to describe an NLU as middleware, but there is a part of it that seemingly, from what you're describing, is acting a bit like middleware.
Exactly. We still have NLU, but
yeah, but it doesn't have all of the.
It doesn't have the middleware feel to it. Yeah.
Interesting. That's interesting approach, that. So that's the NLU side of things. What about the kind of memory side? So, anyone who's worked with conversational systems will know that, you have to, in the vast majority of them, build some kind of sort of state machine where you're collecting data and storing data, and then you're always going back and checking against that data to see what previous things the user has been interested in, and then you're shaping everything beyond that. And it does get a little bit like if this then that rule-based kind of rigidity, and it can get very complex as well if you're dealing with that booking example that you give there, like what time is it, what place is it, what venue is it, how many people are going to turn up, and this, that, and the other. And so you're dealing with a lot of different stuff that you need to always manage. And the booking one really is actually a simple example, because that's predominantly just form filling in the most cases. But if you're dealing with a more not open-ended conversation, but let's say it's content-based and you're trying to find the right insurance policy for you or whatever it might be, then it becomes wildly more complex. So that's how I would describe most systems kind of do it, is some sort of state machine, some kind of variable capture and check-in back on previous answers. I know I've kind of explained a few problems with that, but is there any other things that you've observed from that kind of way of managing memory that has become a problem? And then what kind of solutions do you have to improve on that?
Yeah, so I guess you described the problem quite well. At least I guess we can group all of these as what I guess we introduce a term of like n-order memory. So this is what we would call one-order memory. It's you're talking about, let's say, the same booking or the same insurance policy, and you're trying to even deal with just with one instance of it, right? So this is like first-order memory for us. And you described the issues of first-order memory very, very well. It's like that's basically you said it. Like it's if else, and the moment this state machine or the state itself becomes complicated, is like, how do you even do it? It's basically impossible. And none of the conversational SDKs really help you with it, because the if else statements you got to write yourself, right? So you're basically left at zero, or you're left at ground zero. Now, before I answer a little bit of the philosophy again, because again, memory and our memory module is part of the secret sauce as well. But I'll mention another problem that exists in memory, which is not first order, but like second, third order memory, which is, imagine you spoke about not just one insurance policy, but maybe you have two insurance policies, and then and maybe some other thing that the service allows, maybe your regular payment into these insurance policies, and then you reference one insurance policy, and then you want to access the other insurance policy, and then you want to maybe cross-reference them somehow and say, hey, actually, could you do something with the insurance policies? I'm not an insurance guy.
Can you cancel my my wife's and move it into mine or something like that? Or like
exactly. And so this triggers another problem, is because now you have individual instances to kind of resolve, and so obviously things like co-reference resolution might help with that, but it goes much more beyond that, because it's not just like understanding that it means something mentioned before, or that means something mentioned before, like that insurance policy, without mentioning insurance policy. But it really refers to rather like existing concepts, right? Like it's this specific thing and it's this specific thing. So this is what we call second order memory issues, right? Or like third order, referring to concepts in the past, and many of them. And basically when we think of this problem, what we understood is that this modeling of what you can speak about. So you mentioned state machine as one way to model memory. This modeling bit of how you actually model this world, or what's going on, you can do it in other ways as well. And if you do it in other ways than the classical state machine, then some of these problems disappear. And the other thing is, it also allows you, it gives you new avenues of tackling like the more advanced memory issues, which, or at least they're more advanced for us, those second order memory issues where you have many objects floating around. And so it is about how you model this. And so state machines are perhaps not the best way to describe what is going on. So this is kind of like a little bit of a hint. But then the other thing, I guess, that is quite important, is that it's about grounded dialogue. So it's not just about words that are being thrown around and it's a chit-chat bot, but it's actually understanding what the user says, but then also grounding it to the real world, right? So if I say Peter's insurance policy, it needs to actually retrieve it from a database, or it needs to really find this insurance policy and not just have it as an abstract concept, right? So that is also important, grounded dialogue. And then one thing that permeates maybe all of our technology, which is also quite interesting, is that we have a hybrid AI approach. So between neural networks, which of course are very important to understand surface forms and so on, but also symbolic AI. And merging these two allows a lot of these things to be solved in a more natural way as well.
Interesting. So symbolic, how would you define symbolic AI?
Yeah, so symbolic AI is, I guess, the field that was very, very dominant and popular in, I guess, the 1980s, which is what we find in a lot of these theorem solvers and those programming languages like Lisp and Prolog and all of these. So where the reasoning or the logic happens automatically over a knowledge graph or a symbolic structure, where you define basically concepts and rules of inference, and then new facts can be derived. So the classical example is, you could put into your symbolic AI, you could say all men are mortal, Socrates is a man, and then it basically will deduce on its own that Socrates is also mortal because Socrates is a man. So that is what symbolic AI is in a nutshell.
Right, interesting. That's interesting. So that's interesting. That so you've got a different approach to the NLU that bypasses intents and slots. You've got a different approach to the memory side of things and holding memory and keeping context and all that kind of stuff. What about the dialogue management then? We kind of started getting into that when you were talking about it needs to be grounded in something. It needs to go away and find that insurance policy, but it's pointless just finding it. It needs to retrieve it, and then there needs to be something presented to the user. So what is hold on, we've got a question from Richard, which sounds fairly related. I'll come back to that. Sounds like symbolic AI is an extension of symbolic logic. Is that
exactly, and they're definitely related. So symbolic AI builds on symbolic logic, and symbolic AI is about learning in symbolic logic. So it's about not predefining, not us writing all the rules, not us inventing all the stuff, but rather the AI or the algorithm itself learning how should it apply rules and finding these rules. But then it uses symbolic logic as the underlying principle.
Interesting. Cheers for that, and thanks for the question, Richard. So as we were saying, you've let's take that insurance kind of policy example. Once you've found the insurance policy we're talking about, as I was saying, there needs to be something that the AI gives back to the user, and all of this thing about managing memory and understanding where a user is in a conversation and what responses to serve. That's usually where people would think of that as the architecture or the conversation design element. Like when we're in this part of the conversation, we expect this to happen next, and then we're going to go and grab this piece of data and serve this here. So first of all, what was the issues that you found from existing dialogue management systems when you were first beginning to create Wluper?
So if I was as eloquent as how you described the memory issue, I think the dialogue management issue is exactly the same, just magnified. So it's a lot of if-else statements. If you're here, then you're there. And so what people are used to in industry, I guess, is those flow diagrams of like many different paths through the conversation. So you are in this state, and if this happens, then you should do this, and if something else happens, you should do this. So it's like the memory, except it's even bigger because conversations are even bigger. And just to give an example, if one has just 10 intents, and one looks at a conversation of 5 or 6 turns, that's 100 or 100,000 or 1,000,000 different flowcharts that one needs to write, right? So this is a million if-else statements, which is quite complicated to come up with, and so this is kind of the problem that we found is, and the neural network approaches. So one could say, oh, but they're neural network approaches. It's true, but neural network approaches have also their downsides. One is that they actually often don't work as well as one would hope them to work, and secondly, you have sometimes black box behavior. So sometimes you need to enforce certain things, like if this happens, you really do that, and usually it's quite hard to combine black box neural networks with like business logic that actually needs to happen. And so this is kind of the challenge that we found, and the interesting thing is this, and that is exactly like the third pillar, so to speak. What we found there is that it is also very related to describing the what can go on, as opposed to how it can go on, right? So it is more about, if you are an insurance business, you probably kind of know maybe the state in which the insurance policy can be, right? And it is more about, you need to describe the individual process of what would be the process, forgetting the conversational AI, what is the process of the human without any conversation AI. And that process is usually described already because there is a working insurance policy, a working business. And then it is rather about trying to be clever about translating this into a dialogue manager. And here again, we employ this hybrid of neural networks and symbolic AI. So this is where, and of course, these three parts of our system, they weren't designed independently. They were designed very much in tune with one another. So one works very well with the other, with the third. And so in conclusion, I guess, to overcome this challenge of writing a million if-else statements, there are really not many tricks that can help you, except for, so there's no trick that you can apply to like stick with the same paradigm and hope you will get better. One thing that is important is to, I guess, again, model the space differently, perhaps, and to then go into symbolic AI, so AI that can learn rules and maybe smarter rules than just if-else statements to solve that problem. So that is how we overcame that.
Interesting. I can see you kind of trying very hard not to give away too much of the secret sauce as we were sort of maneuvering through that there. But I appreciate that explaining that and giving us a flavor for the kind of stuff you're talking about. So, what does all of that mean in practice then? So you have a different approach to NLU. We haven't actually spoke about speech recognition a great deal yet. I don't know whether there's something specific you do on the speech recognition side, or whether that's kind of like a third party front end that you kind of put on there. Maybe we can comment on speech recognition before we move on.
So speech recognition is a very, very important part of voice conversational AI. And so we haven't been active in actually producing our own technology or our own models in speech recognition, because we found that for some use cases, the big players are doing a fairly decent job, like out of the box. But then there's also some partners that we've been speaking with that had very convincing showcases where we can see that going into a new domain, we can actually adapt the ASR to work very well in a specific domain, which is very important. So off-the-shelf models, they don't always work in all domains. On the contrary, there are many domains where they fail. So these partners have shown us that by providing data from our side, we can move into those domains. In the long run, that is probably to remain like this for quite a while, but who knows what the future holds. Yeah.
Interesting. We will do this one question from Richard, and then we'll move on to how it all comes together and works in practice. So
yes.
Richard's asking a question. Now, I'm joining a little late, but if you haven't touched on this before, we kind of did touch on memory, but we didn't get into this specific question around how does your or have you come across this issue where you need to account for anaphora or what pronouns to refer to? You might call this linguistic memory. So let's say that, I don't know, someone refers to themselves as a male or a female. How do you remember those kind of things within a conversation to personalize the conversation, or are you predominantly interested in recognizing and remembering the state that the conversation's in, so to speak?
Yeah, no, very good question. So in practice, or rather not in practice, in the like production system, or the system that is being tested and used more for the production purposes, not the experimental parts that we work on, that doesn't have such level of customization, in the sense of if I refer to this insurance policy as the insurance policy ABC, right? And then you say, oh, what about ABC? That won't work, right? So this on-the-fly learning of new names for things. For us, it is much more important to just be able to recognize, if you speak about identifiable or more objectively identifiable terms of this insurance policy, let's say, to then be able to identify. So if you say my wife's or Peter's or insurance policy with a specific number, then it should identify it. However, thanks very much for the question, Richard. I guess if you look at what we have been developing or thinking about in the research team, which we still have. So as a company, we are a commercial entity, so we are very much interested in bringing our things into production, to the real world, and commercialize. However, we always try to keep a research unit that actually pushes the frontiers of technology. And there we have been actually exploring and thinking about ideas how to eventually, at some point, introduce such sort of personalization on the fly.
Interesting. I mean, it obviously shows that the research team and the kind of dedication to investigating different ways of solving these problems is evident, obviously, because it's present in every single piece of the technology that you've created, which is definitely unique. I've definitely spoke to a few companies who have got a different approach to speech recognition, NLU, stuff like that. But this is certainly I've never come across quite this kind of solution before. So I think there's definitely something very unique about it. So what then is the impact on the end user? Because obviously all of these systems ultimately are used by people trying to get jobs done, trying to accomplish tasks, trying to do something. And the idea of all of this research to make things better is to make that front end easier, essentially,
Yes.
in many cases. So the different approach to NLU, the different way that you're approaching kind of memory and context, and the different way that you approach dialogue management, what's the end result of that? Can you give us some examples of how it manifests itself in practice?
That is the main question, actually, because all of this technology, if it doesn't make a difference, it doesn't matter. So the one thing that we always speak about, and by most accounts, we would be referred to as a deep tech company. We internally, we actually don't like that term as much. What we much more like to be referred to is as applied AI company. So actually being able to apply this tech in the real world. Now, the question that you ask is like, what is the impact or difference that I guess is happening already? But I think the other thing that one needs to keep in mind is what will hopefully or could be happening in the future. So I think both of these perspectives are very important to keep in mind. So conversational AI, and I'll answer both. So we have our technology already being developed for very real use cases, and we've run trial runs with test users, but we are also going to be live at some point this year, hopefully. So there is concrete impact already. Now, and the impact, let me focus on that first, is actually quite clear. So we have different products. So we have we're working on the full conversational system as a product, but then we also took out parts of it, the NLU perhaps, and maybe parts of the other components like the natural language generation and dialogue management, and we created a smaller, more lightweight product. And this is the product that seems to be applicable to the fieldwork domain in a more scalable way, where we don't actually need to customize as much from client to client. Now, the advantage of that specific product is that what has been possible or actually impossible in the domain at the moment is that all of this issue reporting or all of the maybe getting information about locations, or you go out, you need to fix something as a contractor, as a field worker, and there's no way of actually getting any information out of the app because the apps are quite primitive. Plus, the information is there; it's there in the backend and in the database and in documentation, but it's really hard to access that documentation. And basically, and to report issues, like you walk around and say, oh, this is what has been done, or there's a new issue. And so our NLU allows for such sort of interaction in a much more intuitive way. So this is, and one that works. So instead of every second time being very frustrated that something didn't work, it actually works. And also, as you can see, it is neither as part of the big players platforms, nor is it customer service where you call something. So it is actually as an application in the real world. And that is, I guess, the transition to the second part of the question is not only what is possible now, but what is going to be possible in the future, and not in the faraway future, but in the near future, is that we will be able to experience voice technology and conversational AI, not just in the big players' platforms or via call centers, but actually in everyday technology. And perhaps it will start more in industry, such as fieldwork, where it's not end users, but it will eventually reach the end user as well. And there will be much more conversational AI systems in the world. And at the moment, if you were to speak with many businesses and ask them, oh, do you need conversational AI, or how would you like to use it? The answer is like, most people don't know. And it is quite normal because there isn't conversational AI. It's a new frontier. It's something that isn't there yet. So people cannot really imagine it. If you ask them to imagine flying cars, they will say, yeah, maybe I need one. But I guess once they exist and they would be convenient, people will love them, for example. And so something similar is happening here. And concretely, if you now focus on the end user and when they interact with our system, I can walk you maybe through one conversation or example conversation of what is actually possible today. So this is not scripted. This is not, and I won't show it. I will just pretend. So the system and the user, they can have the following conversation. The user can say something. Let's go. I don't know the insurance space. We've never built a system for that, but in the transport space or navigation, this location and navigation space, the user can basically say, oh, I would like to go to London, and the system would come back and say, do you mean London King's Cross, London Paddington, or something else, right? So it will give you back the options. And then the system will say, oh, actually, London Paddington, and then the user would, so basically, and then the user would say London Paddington and by bus, and then the user maybe would say, and 5 p.m. and the user wouldn't specify 5 p.m. is it arrive by or depart at, and the system would say, oh, do you mean departure time or arrival time? So it would actually trigger a disambiguation question of a different sort. So it wouldn't give you disambiguation of actual values. It would rather of the concept. Is it the arrival time or departure time? And the user could continue and say, oh, 5 p.m. Then the user could also say, oh, actually, by the way, I don't want to go by bus, I want to go by train. And so you can just have this back and forth with the system clarifying questions when it doesn't know for sure, the user correcting things and or adding information. And also another thing that is possible is you can interject. So you can say, oh, actually, by the way, what's the cost of that? Or when does London King's Cross open or close? So you can just ask something in between, and it would return to the main conversation eventually. And this conversation is actually possible already. So it is. So this is what it works. It just works, and the system, instead of failing at a specific point, it actually asks the user much more often to clarify little and small things, as opposed to just failing at the very end.
Interesting. It's because those kind of conversations can get quite complex, can't they? I mean, if you think about we always talk about the potential of these systems, and you think that it's really, you should be able to do anything you can do on your phone, more or less. It doesn't rely on a visual. You should really be able to do with your voice or what have you. And a lot of the challenges that come from it is a lot of the things that we've actually spoke about, to be fair. Like, let's say you're ordering a pizza and you want to order a pepperoni, and then you want to put extra mushrooms on it, and actually, no, I mean jalapenos. Even just that, no, I mean jalapenos, no, means I don't want the mushrooms anymore. I want jalapenos instead of those mushrooms. And all of a sudden, things start getting very messy. And all it takes is for someone later on to say, actually, can you make that two? Is that two pizzas or two lots of jalapenos? So it's like it can get very, very complex. So it sounds as though this kind of stuff will help make, because the whole point of conversational AI is to make the interface easier to use, isn't it? That's the whole point.
Yeah.
And the thing that makes it challenging to use often is that either it doesn't recognize the user, or this issues that we've been speaking of in this example of the pizza order, it fails because you can't manage the conversation basically. So it
Yeah.
sounds as though all of this stuff culminates to a more positive user experience, which is obviously fantastic.
Exactly. And just to speak about the jalapenos example, or if the system basically finds ambiguity and it isn't super confident in what it has understood, it will ask the user, right? There is no harm asking the user, do you mean 2 jalapenos or 2 pizzas, right? And obviously the system will appear maybe less intelligent than a human, but it will not appear completely, utterly mindless as most of the systems appear these days, right? Like if you ask any of these things, or if you say any of these things, they never work. And maybe one more thing that I will mention on what you said about the vision is that theoretically you should be able to do anything you can do via finger touch and press and everything else with the phone now, you should be able to do with voice eventually. And that is definitely our opinion as well. But at the same time, it is a step-by-step approach. As we always say, it's a step-by-step. So at this stage, we haven't automated all sorts of reasoning, but we are tackling one domain and one problem at a time to allow for more of such interactions in the future.
Interesting. We started the conversation hinting towards domain-specific NLUs and stuff like that, and it's something we have spoke about on the podcast a number of times in the past in terms of, NLUs for the faults that we've outlined around intents and slots and stuff like that. Regardless, they're still being used. They're still, lots of systems use that approach. They're still being adopted. Certainly over the last year, because of COVID, things have been fueled quite a lot, and so they're being used more and more. And in all kinds of different areas, and for your likes of Microsoft and Google, they have very general tools that anyone can use in any industry and get on with it, kind of thing. But then you do have the signs of domain-specific NLUs. I mentioned it at the beginning of the podcast. Kai from Casisto, purely a chatbot platform that only focuses on banking and finance. And presumably that's because over years they've built an NLU that's very good at recognizing financial terms and financial entities and all that kind of stuff. And so we've referenced a few times that will we see domain-specific NLUs pop up, and will that be the thing that kind of segments some of this market a little bit? But it's requires a lot of dedication to build a domain-specific NLU. So I'm just curious about because we had Balto, Mark Bernstein from Balto on last week, and he was talking actually the reverse of that, which is that they purposefully focused on general stuff, which means that they can cater for a wider number of use cases. So there's two different approaches at play here. Some companies are trying to go general on purpose. Some companies are trying to go domain-specific, industry-specific on purpose. What's your thoughts and feelings and philosophy on why you're taking this domain-specific approach?
It's a very good question. I guess there's really two fundamental answers to that. One is, I guess, inspired more by linguistics itself, or just language, not even linguistics. Language is ambiguous, so we have the same name or the same word for many different things in the world. So when I say apple, probably based on the context of the conversation, I might refer to the company, but I might be referring to the fruit, or I might be referring to something else. If I say Mac, do I refer to the computer, to the McDonald's Mac, or to mac and cheese, or to the makeup company? And somebody pointed out there's some more Mac, so Mac seems to be a very popular word.
It's a quote. It's a raincoat.
Yeah, there's a raincoat. Oh yeah, exactly. So and the question is, when you have a generic NLU, right? What do you even expect it to give you back, right? I wouldn't be able to answer that question. And I think the best a generic NLU could give you back is give you back all the options and tell you like some sort of signaled, hey, this is ambiguous, you gotta do something about it. And so this is kind of maybe the best case scenario. Now, before I answer why domain specific, or what maybe domain specific is from our perspective, I will answer maybe another fundamental, more of like economics argument for for going maybe more domain specific at a time, is that going generic or going domain agnostic is a very, just by virtue of you are building. So if you want to have similar quality as the domain specific people, you are doing what they are doing, but just many times over. Like as many domains as you think is generic enough, that is like your effort times this individual effort, because they could be using your approach just for a single domain, right? So the question is, why to go into this much harder effort when you are still haven't even solved it for one domain, right? So that is maybe the more intuitive answer. Maybe will be proven wrong, but there are arguments against it. Now, what domain specific means, for us at least, is not even that you reduce ambiguity, but you do reduce it. So you might still have domains where you have a single name or word for many concepts and objects. But what we mean by domain is actually defining this what space a little bit, and not necessarily everything the user can, or how the user can speak in this domain. That is what we try to keep as flexible as possible, but it's rather the concepts and objects that are available to be discussed, right? And so, and by this, this is what we mean by domain specific, and by specifying this what and the domain itself, right? So if you are domain specific, you got to be able to define in technical terms what a domain is, right? And so for us, it is this what is it available, what is the functionality, what are the concepts available to the user that the user could reference by voice and conversation. And by defining the domain, one actually has a much simpler job in modeling this domain and actually solving what the user wants. Yeah, so that is our take, at least.
Interesting. And presumably over time, if you can solve a domain for, I don't know, let's say insurance, because we've been using that example, and you can solve something that works really well for, banking, you can solve something that works really well in retail. Over time, you end up with that generic NLU kind of anyway, don't you? A little bit, because by virtue of adding them all together, then you just need really a front end that can determine which NLU is best off to handle this query, basically.
Exactly. So exactly, when we say domain specific, it doesn't mean we only go for one domain. It's rather we do one domain at a time, right? So many one domain systems as opposed to one generic system. Exactly.
That's fantastic. I love that. Well, I think if I could summarize this conversation, I would summarize it in the words of Richard Vorzecker, which is, thanks, Nikolai. I really enjoyed this conversation. Reminds us how challenging conversational AI truly is, and how a step-by-step approach you advocate for is needed to build on our successes. The linguistic, cognitive, and logical challenges are clear, and it was too long to even fit on the screen, Richard, and clearly much more difficult than many people are imagining. It's great to see some companies like yours are methodically taking them on. And I think I agree with everything that he said. I genuinely think that the approach that you have and everything that you've explained has been absolutely enlightening. I mean, drawing out all of these challenges that exist with the whole pipeline that exists currently, that I think we're on the verge of taking for granted, to be quite honest. It's like that's just how it is. Speech recognition systems work like this, and NLU works with intents and slots, and dialogue management requires these spider webs, and we do memory by capturing variables and checking them and building our steps. This is almost become an industry standard practice, which at times can kind of lure you into this false sense of security that the industry has matured. Well, in actual fact, conversations like this make you realize that actually it hasn't been solved. It hasn't actually matured. It's still very early days, and there's some big problems to solve. And I think you've outlined really articulately how Wluper is on a mission to do that. So thank you very much for your time, Nikolai. It's been an absolute pleasure.
Thank you very much, Ken. Likewise. Awesome conversation.
Where can people find out more about Wluper if they want to check out the research that you're doing? If they want to try and maybe get under in the door and try and get some trials off the ground, if they've got an idea or a way that they can utilize this technology, what's the best place for them to do that?
Yeah, so it's on our website, so wluper.com, Wluper with a WLUPER.com. Yeah, just reach out. Our research, some of it we publish actually, so you will find it there. And you can find also how to reach us, and that would be the best way. And
Perfect.
Feel free to reach out to me on LinkedIn, just Nikolai Rozanov on LinkedIn, and or by email.
Fantastic. Nikolai, this has been an absolute pleasure. Thank you so much for joining us. Thank you everyone for tuning in. If you're tuning in live on LinkedIn or YouTube, it's been an absolute pleasure. If you're listening back on the podcast, then it's also been a pleasure. And next week, we will be speaking to Andrew Richards of SoundHound, and we're going to be talking about speech recognition in noisy environments. So if you're building something, actually, Nikolai, this might be relevant for you, working in the field with conversational applications, you're working outdoors, there's noise, there's traffic, or you're driving in a car. How do you build a speech recognition system and a model for use cases that are outdoors? So it's going to be incredibly interesting. So hopefully we can see you all there. Nikolai, I'll say it again, it's been an absolute pleasure. Thank you so much for joining us. We'll see you next week.